All right, welcome to our first Math 3 lesson, and we're going to talk about piecewise functions. So when I talk about a piecewise function, I have at least two different equations that are being used to define this function. So I have multiple pieces that are put together to create this one function. And each of those equations or pieces of the function are going to apply to a different part of the domain or different x values. So it's possible that the pieces are all linear, or we could have a variety of different forms: quadratic, exponential, cubic. A lot of the ones that we are going to encounter will be linear, but it is possible to have other forms of equations mixed in there. And since these functions are a combination of a variety of functions, there is no parent function. Now we have to think back to Math 1 when we were graphing linear inequalities. If we have an open circle, that means that point is not included in our domain or range, and it's for inequality signs that do not have an equal to. On the opposite side of that, if I do have an equal to sign, that means we get a closed circle and the point will be included in the domain or the range. Now we will see some continuous piecewise functions. We will also see some discontinuous piecewise functions where I have chunks of these graphs that do not connect. So I couldn't trace the whole thing with my pencil. But in order for it to be a function, it does have to pass that vertical line test, meaning every input has one unique output. So we're going to go through a couple examples together. So the first one I'm going to look at, and I'm going to do this in two different colors, even though I hate doing math in pen, and you know that, but I'm going to do this in two different colors just so that we can see the difference. So I've got a purple and a blue. So I'm going to start with x plus 5. So this function x plus 5 lives for all x values that are less than -2. I'm going to show you a couple different ways to do this. First, I'm going to start by actually making a table. If I'm going to do it with a table, I have to include this value. And then I need to do numbers that are smaller than -2. So that would be -3, -4, and so on. And then I'm going to take these x values and substitute in here. So -2 plus 5 would be 3. -3 plus 5 would be 2. -4 plus 5 would be 1. And -5 plus 5 would be 0. Now I can graph these points. But because this does not have an equal to, this point right here is an open circle. So I'm going to go to -2, 3, and put an open circle. And then these are just regular points because they exist on this line. So -3, 2, -4, 1, -5, 0. And since there's no end point there, it's going to get an arrow. So that's the first one. I'm going to do the same thing here with the second one. -2x minus 1. And if you're doing a table, I usually do 3 or 4 points just to make sure I've covered my bases. I have to include the point that's here in my domain statement. And then I'm going to go bigger. So I'll have -1, 0, and 1. So -2 times -2 is +4. minus 1 is going to be 3. Negative 2 times negative 1 gives me positive 2. Minus 1 gives me 1. 2 times 0 is 0. Minus 1 is negative 1. Then 2 times negative 2 times 1 is negative 2. Minus 1 would be negative 3. Now in this case, this is going to be closed because it has an equal to. Now you're going to notice here, in this case, it's the exact same point. So when that happens, my closed circle wins over an open circle. So because of this being the exact same point, I'm going to fill it in, and this one wins. So then negative 1, 1, 0, negative 1, 1, negative 3. And then I'm going to connect those points. Pretend that that was a straight line. So that's graphing if you're using a table. We'll do one more where we make a table. So I'm going to do this here. So let's start with 2x plus 1. Now I have to include 1, and then these are going to be numbers that are bigger than 1. So 2, 3, 4. Now, the nice thing about Math 3 is we get a calculator the whole time, so I don't have to do this in my mind. So I can do 2x plus 1 here. I'm going to go to settings now I'm doing this in my Desmos graphing calculator on my phone. You could do this on your TI-84 or whatever you have as well. I'm going to turn this into a table. Now I need 1, 2, 3, and 4. Oops. Goodness gracious almighty. All right, so here's 1, 2, 3, and 4. So I've got 3, 5, 7, and 9. This is going to be closed. So I'm going to go ahead and graph these. So 1, 1, 2, 3, 2, 5. I'm not going to have room for all of these. So I'm going to connect these. Now I didn't have room for 4, 9, but because it's continuing and there's no endpoint, we'll have that arrow there. All right, switching over to 1/2 x minus 3. I have to include 1. So I know that because there's a 1/2 in there, I'm going to have some that are going to be in between tick marks. So what I'm going to do is I'm going to turn this into a table. And I'm going to look at my values first. So 1 is going to give me negative 2.5. I don't feel like graphing a bunch of in between tick marks because I am not as accurate as if I'm graphing on a whole tick mark. So I'm going to look at these numbers that are less than 1 that are going to give me a whole number. So I'm going to pick 0 and negative 2, and I'm going to graph negative 3 and negative 4. I do not have to graph every single tick mark in order. I can pick a couple that suffice this less than 1 as long as I include that one that's here in my domain statement. So for 1 here, I'm at negative 2.5, and that's going to be an open circle because there's no equal to. and then 0, -3. Oops. Yep, that's right. And then -2, -4. All right. So this graph is wildly different than our previous graph because it is discontinuous. I have a chunk down here, and if I was tracing it, I'd have to pick up my pencil and start again over here. Is this a function? Well, I'm traveling along and I'm owned by the blue function here, the 1/2 x minus 3. But if you'll notice here at 1, I have, if I draw an imaginary vertical line here, I have an open circle and a closed circle on the same x value. Since this is open, remember this point does not get included in my domain or my range. It would be a less than symbol. This point does get included in my domain and range. So since I have an open and a closed circle on the same x value, this is still a function. It's a discontinuous function, but it is still a function. Here, however, on our first example, this is continuous because I can trace this without ever lifting my pen. This is still a function because at no point in time do I have two y values with one specific x value. So here we're still good. So I'm going to go through 2 more examples with you here. And I am going to start doing things a little bit differently. Instead of doing a table of a whole bunch of points, I'm going to just pick 2 points and call it a day. So I'm going to start with this -x divided by 3 plus 4. And I just turned that into a table. This looks awful, doesn't it? Oh, where's +2? Here it is. Now, I still like to put my values into a table just because it makes my life easier. So I'm going to pick 0 as one of these points because it's a whole number here. So this is 3 1/3, which is going to be gross to graph, but we can do it. We got this. This is open. So here's 2 and 1, 2, 3 1/3 is like here-ish. And I had to do less than 2, which is why I picked 0. So then 1, 2, 3, 4. Here's my next point. Connect those 2. Boom. Call it a day. So you don't always have to do multiple points. If you pick 2, you're still going to be okay. So let's do the same thing with 4x minus 2. So I'm going to pick 2, and let's say I'm going to pick 3. So 4 times 2 gives me 8, minus 2 gives me 6. I'm not going to have enough room for this one. 4 times 3 gives me 12, minus 2 gives me 10. I'm going to have to fudge this one. I didn't give myself a big enough graph here. This will be closed because I have an equal to. So 2, 1, 2, 3, 4, 5, 6. This is going to be closed. So automatically I know I have a discontinuous graph. And then 6, 7, 8, let's call 10 up here. And there we go. So it's discontinuous, but this is still a function because I have open and closed on the same x value. Now this number 4 is the last one I'm going to do with you today because now I have 3. Gross. It's totally fine, I promise. It's no different. I just have to do 3 different pieces. So I'm going to grab one more color. So I'm going to start with negative x plus 4. And again, I'm going to just do 2 values. And I have to include what's here. Less than 0, so I'm just going to do negative 2. I just picked a number out of the air. So negative 0 is just 0, plus 4 gives me 4. Negative 2 is positive 2, plus 4 gives me 6. So I'm going to go ahead and graph those. Oh wait, this is closed. I have to remember to do that. 1, 2, 3, 4. And I usually make my domain values here big, just for my brain, so I can see it better. The rest of the points don't really matter as much size-wise. You can just make them a regular sized point. And then negative 2, 1, 2, 3, 4, 5, 6. And then I'm going to connect these. All right. Now this one here in the middle, the 2/3 x minus 1. You'll notice this is the first one we've seen that has a start and a stop. Well, guess what? Those are the 2 values that I need to put in here. So I'm going to go ahead and find these x values. You can do this with your calculator if you want, or I mean the y values. Totally do this with your calculator if you want. This first one's not that bad. This one, when I do 5 times 2/3, I get 10/3 minus 1. So this ends up being 2 1/3. And again, you could totally do it in your calculator if you wanted to. I would do 2/3 times 5 minus 1. Kaboom. So 0. Now this one, this is going to be an open circle because it's less than. This one is going to be a closed circle because it's less than or equal to. So 0, negative 1 is here. That's open. And then 5, 1, 2, 3, 4, 5, 2 1/3 is closed, and I'm going to connect in between those 2. All right, this last one. Really, I don't need a table, but I'm going to do one and show you why I don't necessarily need a table. So it's bigger than 5, so I'm just going to pick 6. And both times, that's my output value. It's just 2. It's going to be a horizontal line. This will be open. So there's an open circle there at 2. And then the rest of the way, it just goes that way. Now, this is not fun. I understand that. Should have made my graph a little bigger so we could have been more precise. But regardless, even though this graph is discontinuous, and it's got that funky thing right there, every time I have 2 points on the same x value, one is closed and one is open. So this is still a function, even though it's discontinuous and kind of funky looking. So that's graphing piecewise functions.